Welcome back to Saxon Algebra 2. We're in lesson 28. We're going to be talking about complex fractions. We know the denominator-numerator rule, which tells us that we can multiply the denominator and the numerator by the same number and the value stays the same. Now I can illustrate this with 1/2. I can multiply both the denominator and the numerator by 3, and we have 3/6. And this is the same value as 1/2. It's just that we've split it into more parts through the process of multiplication. But it means the same thing. It's still half of whatever number of units we have. So we can use this rule that we have proven that we know is true with complex terms in our numerator and denominator. So for example, if we have let's say we have A over B over C over D. What we've been doing in the past for this has been using keep it, change it, flip it, which works. It works well. But there is another way. We can use whatever's in the denominator and flip it. We'll use the reciprocal of this to multiply both the top and the bottom, and then there will be some things that cancel out. So, for instance, in this case, we would multiply everything by D over C. And what happens is these two cancel out here, and this becomes 1 in the bottom. So what we end up with is A over B times D over C. So our answer is AD BC. And that is the result. Now let's see if we'd get the same thing if we had used keep it, change it, flip it. So if we had A over B, C over D, which is the original problem, if we put this in our keep it, change it, flip it format, all right, this is the original problem, A over B divided by C over D, and we translate that to A over B times D over C, we get the same answer of AD over BC. You can see they match. So this is a way that works, but this is also a more simplified way that works. And I'll show you why it's a little bit simpler with problem 28.1. So I'm going to let you pause and take notes if you need to. And I'm going to clear the page. So in 28.1, we have this complex problem. We have A over B all over x plus y over b. All right, that's a pretty complex problem, and we could keep it, change it, flip it, and it would work just fine. But this time what we're going to do is we're going to use the denominator reciprocal multiplication method. So we're going to say b over x plus y, and we're going to multiply both of these by b over x plus y. So what happens is this cancels and this cancels. So this is 1 on the bottom. So we end up with a result of AB and b times x plus y. And we can see that we can factor out the b here. So that leaves us a over x plus y as our result. And that was a little bit faster, I think, than keep it, change it, flip it. Let's see if it's a little bit faster. I'm going to go ahead and write this in keep it, change it, flip it. Okay, so we have, looking at that, it's a over b divided by x plus y over b. So I'm going to keep the first one, change the sign, and flip the fraction, which is what we multiplied by. These cancel, and then this is the same answer. Okay? So either one that you want to use will work. This is a little bit more, when you get more and more complicated, this might be easier than this one. just depending on your perspective. I will say that in this method, we were able to factor before we did the multiplication. So that was a little bit easier in my opinion. But at the same time, we could have factored b out right here and just had a over x plus y and done it all in one step. So it's entirely up to you which one you want to use. Let's do 28.2 and see if we can use just our new method and use it successfully. So 28.2 is a over a plus b divided by c over a plus b. All right, we're going to multiply that by a plus b over c all over a plus b over c. All right, the first thing I see is that these cancel. We knew they would. This cancels also, so we have a over c in one step. So that's actually pretty quick. I highly recommend trying this method instead of keep it, change it, flip it. If keep it, change it, flip it is comfortable and you want to go through the extra steps it requires, do that. But this is also a valid method for you. All right, so moving on to rationalizing the denominator. We know that we don't like to use square root symbols in our denominator. Or if you didn't know that, now you do. That's not something that algebra really likes because the radical symbol can be an irrational number. We typically like to avoid that. So we want to simplify or rationalize our denominator so that it makes sense to us as much as possible. An example of that is 3 over 2 times the square root of 5. We know that we can multiply square root of 5 times the square root of 5 and get 5, right? That's just logical. So we're going to do that. We are going to multiply similar to what we did earlier, but we're going to multiply just by the square root of 5 because we know we can use any number as long as we multiply the top and the bottom, then it will remain the same. So we're going to multiply times the square root of 5 on the top and times the square root of 5 in the bottom for the numerator and the denominator. And what we end up with is 3 times the square root of 5 here. And because 5 times the square root of 5 times the square root of 5 is 5, we end up with 2 times 5 here. So that ends up being 3 times the square root of 5 over 10. And we are able to see that as a real number now. And we have rationalized that denominator. Whenever we have a square root in the denominator, we want to get rid of it. So we want to try our best to rationalize that away. All right, let's do 28.4. And then that will be our last problem for today. 28.4 is 2 over 3 times the square root of 12. So we are going to multiply times the square root of 12 on the top in the numerator and in the denominator. I gotta start using those words more instead of just top and bottom. And this is going to be 2 times the square root of 12. And because we know from here, this is going to be 12, be 3 times 12. This is going to be 36, right? All right, but we can rationalize this even more. We can simplify this a bit more because we know that 12 is 4 times 3. So we can pull the square root of 4 out, and that's a 2, and we'll multiply it by this constant. So 2 times 2 is 4. So we can reduce this to 4 times the square root of 3 over 36, but we are not done. We can reduce this. We know that 4 is a factor of 36, so we know that this can be reduced a little bit more. And we know that 4 times 9 is 36. So we can reduce this to the square root of 3 over 9. 1 is that invisible. When it's just 1, you can write it or you cannot write it because 1 is understood. So the square root of 3 over 9 is our final answer for this problem because we were able to reduce it as much as we were. All right, and that is all we have for lesson 28. If you have any questions, please feel free to contact me. Now, I'll see you in lesson 29.